but you can follow along by playing around in the site using these links here. There's a link to this slideshow in the Lightning Talk sign-up document. What is the Philadelphia Area Archive site? It's basically a finding aid site. It aggregates and displays EAD finding aids from a variety of institutions in the Philadelphia area, some small, some large. It's been around for a long time, and it existed as one of those lovely Java, XML, XSLT monstrosities that nobody likes to mess with anymore. But it became a service that Penn Libraries was committed to maintaining, but one that the hardware and the software, we lost the expertise for it in our staff, and it was just impossible to extend, and became, this. I'm sure this is all sounds very familiar to everyone. It was time to redesign it, and naturally, we've accumulated staff expertise in Ruby on Rails and Blacklight applications. So we looked to Blacklight to create a sufficient, highly sustainable new version of the site that would have something like feature parity as the old site, but also set a stage for incremental improvements in the future. A natural question to ask at this point is, why did we not use ArcLight? Well, one of the features of the finding aid site that we had been running is that it doesn't offer a inventory level discovery. If you're familiar with EAD, you have some metadata, and then you have a bunch of like collection objects with more metadata about them. ArcLight provides discovery of those more nested elements within EAD, but we weren't concerned with that. Also, I had in the past worked on a Spotlight project, and I was a little bit wary of working in the Starlight domain when I was going for a project that was highly sustainable and that wouldn't require a lot of staff maintenance or long development time. We also, as an aggregator of EADs from the community, didn't have control over the metadata. We couldn't easily recommend that institutions make changes to the structure of their EADs. We had to work with what we were getting. So I planned this up. I estimated 6 months for the project for 2 developers. You'll see how that turned out. One of the high priorities was to improve the aggregator process and make the status of it more visible to our partner organizations. We wanted to do as little as possible Blacklight, as minimal as possible Blacklight customizations so that it was easy to upgrade and maintain the application. But we did have to do some work to devise, not devise the gem, to devise custom display components for the EAD metadata and collection display. So here's a little dashboard of our harvester. Each of these links on the left are our partner organizations. They can see each day how the harvest went, whether there are any errors. Usually it's XML parsing errors. They can see by themselves and address those things and fix the EADs for the next harvest. Here's the look of the site, so search results. I learned a lot about medical quackery in the course of this project, as well as EAD and view components. It's pretty plain Blacklight. One thing that we also had to do was build in some integrations with our Aon special collections requesting tool. Some of the materials in this site are housed at Penn Libraries, and so for those, we made them requestable. But most of the items in the Philadelphia Finding site are not from Penn, so they are not requestable. There's a lot of diversity in the way that inventory level metadata exists in EADs. If you look back, this is a relatively flat structure. We've got a collection and then a bunch of items inside it. But this particular EAD came from Princeton, where they have an ArcLight install, so they're much more, I believe, collection centric in the metadata. It's very rich and very nested. So there were some problems in our view components that render this that were interesting. Some unexpected issues that we ran into was that, learning EAD is complicated metadata format. There's a lot of subtlety to it. There's markup within the metadata, which is horrifying. View components were a learning curve, but I'm a believer now. We ended up writing our own document component and document title component, and that's it, to customize the display in the way we wanted. It's hard to limit scope of the project. Anytime you're doing a redesign, everybody wants X, Y, and Z done. We harvested directly from archive space. There's a massive usage of Docker, actually Docker Swarm within Vagrant. It was our development environment and our deployed environment here. So we had a lot of a learning curve working with our DevOps person on that. That's a whole nother lightning talk I could do on our development environment here. So to wrap up, because I'm running out of time, our aggregator is running very smoothly. It runs 3 times a week. It takes about an hour. We're harvesting less than 15,000 records, so it shouldn't take a long time. Our partners love being empowered to deal with their own metadata issues. I love that too. Before if there was an error in one of their EADs, none of their things would be harvested. Like an exception was raised and it just broke everything. I have to give a hooray for Blacklight. It made this project much more quick to bring up and conceptualize. There was very little thought that went into the searching and faceting behavior. All of it was just, sort of the EAD specific stuff and the requesting stuff. But being able to drop Blacklight in and just have all of that functionality built in is great. It was also a joy to work with, modern Ruby and Rails and Blacklight. And I'm really grateful for that. The real project duration here, I estimated 6 months. It ended up taking about 8 to 9 months, depending on when you consider the project complete. So that's not too bad. Not too bad. That's it. I'm happy to answer any other questions in the Slack. Thanks for the opportunity, and check the site out.
All right, thank you, Michael. Our next lightning talk will be presented by Bill Duber from the University of Michigan. An analyze string, not text, field type for solar. Go ahead, Bill.
Okay. Let's see. Are people seeing slides?
Yes, we are. Thank you.
Awesome. Okay. So analyze string type in Solar. This is just another in my ongoing effort to convince everybody that you really want to do all your string processing inside of Solar as opposed to in your indexing and or query code, because it's always nice to have code in one place. So when I say an analyze string, what I'm talking about is having a string type, a Solar string type, but that you can use the same sort of filters and tokenizers and crap like that that you usually restrict that are usually restricted to Solar text fields in your schema or managed schema file, whichever you use. Okay, so the real problem I'm trying to solve, among other things, is that we have an author browse, which people swear up and down that the patrons are going to use. I'll believe it when I see the numbers. But basically, we want to, suck out of Solar by the export facility a list of all the things that we call an author and the number of documents that they appear in, and then have a big list, and then so people can click through. But of course, we don't want to just store them as we get them out of the mark, because as we get them out of the mark is sometimes nonsense and often needs normalization of some kind. So we need to do that. So this is just an example of what it would look like, what it does look like. right? If you search for Twain comma Mark, we find any exact matches. We find a couple beforehand, so you can kind of see it in context. We find the couple that come after it alphabetically. This is, and show those, and you can page through, and it's all lovely. But of course, we don't want you to have to just type capital T WAIN comma Mark, right? We'd like you to not have to worry about capitalization or diacritics or any of that stuff. So here's a, for those of you that speak this stuff, kind of a pseudocode text field that we'd use for author browse. First, we do some character substitutions if we need it, because in our world, author also means like committees and conferences and crap like that. So we use the keyword tokenizer, we mess around with the punctuation, we try and deal with case folding and normalization, get rid of diacritics and that sort of thing, do whatever it is that we're doing to deal with CJK, probably then deal with spacing and stuff like that, right? So we want to do the same thing we do with most of our search fields, right? Which is to take away all the stuff that might make it harder for people to find things. So in terms of doing the queries, right, one exact match on that first line is just author is whatever the people put in, right? If they type Twain space Mark, it should find Twain comma Mark and call that an exact match, but otherwise not. If we want to get this stuff beforehand, what we're really talking about is sorting them by author in this case, right, alphabetically, and then getting a couple before and 10 or so after, right, and then we display them as I showed here, right? We display the ones that we saw before, the exact matches, and then the ones that come after alphabetically, which seems great. But the problem is range queries don't run the analysis chain of a text field, right? So all of our getting rid of the diacritics, all of our lowercasing, all that stuff, none of that happens when you try and do a range query in Solr on a text field, which was kind of a stopper. So one way to do it is to say, look, don't do that then, right? Just use a string type, which just takes whatever you give it. And right, said instead of doing all this stuff inside of Solr, do the transformation outside of Solr, right? So you have some Ruby code or whatever, you figure out what you want to do, you make sure you do it the exact same way at index time when you're running your indexing code, and at query time when you're running your Blacklight code or whatever it is that you have. Make sure you don't miss any, make sure if you have multiple applications that they're the same, and make sure that all your versions of ICU are the same if you're doing ICU-based, Latinization or diacritic removal, whatnot. And I find that distasteful because as soon as I have code in more than one place, things are going to get out of whack. We also had problems with not all of our stuff is Ruby, right? And some of it's Java. We've got some Perl lying around. We're starting to get some Elixir lying around. And then we're talking about trying to make sure the actual versions of ICU that we're using are the same so that the normalization process is the same. So, so I started messing around inside of Solr and came up with something that does this. So on this screen, we're seeing just what would be kind of a normal field type that you might use for this sort of thing, right? So it's called browse key analysis. In this case, it's a text field. We keyword tokenize it, which is, I don't know if people know that it's really poorly named. The keyword tokenizer just tokenizes into one big token. Do the ICU folding to get rid of diacritics and uppercase letters. I pulled the word the off the front because if we have a million conferences that start with the word the. Whoop. Trim filter to get rid of spaces, right? All that stuff. Then I create another field type of type com.build.uber Solr schema analyze string, and we pass it the name of the field type from which we want to use the analysis, and then create a field, in this case author browse, that uses that type. So the field name author browse is using type browse key. We flip up to browse key. Browse key says, hey, take whatever you're doing in browse key analysis, this thing here, and turn it into a string. And so what I've got now is a string type, right, which the range analysis will work fine with, but has gone through all this screwing around to come up with, in this case, the quick brown fox with lots of other stuff in it to just quick brown fox. It's a real Solr string, which means it behaves as a Solr string does, but I didn't have to do any of that transformation outside of my Solr process. I can just send text to it and it does the right thing. This also turns out to be a really good exactish type, right? Where you want something to only match, you want to really boost something if people give you exactly the right title, except for maybe they put a the on the front and you don't care about uppercasing and punctuation and whatnot. Again, I'm on a crusade. Don't shy away from using custom Java in your Solr process because it's really not that, well, it's hard to walk through because they do enormous, incredibly complicated things at times to make it very efficient. But I've created, I got a couple repos up that just make it easy. And one of them you can create, this is what I'm describing here, an analysis filter just by implementing a method called munge in a subclass of one of my things that takes a string and spits out another string. And you can create a filter that way. And here is where you can find all the code I've just been talking about. And that's all I've got. Hopefully leave a little more time for other people.
All right. Thank you, Bill. Our next talk will be David Kinzer from Temple University, who has presenting 2 useful RSpec tricks newly discovered. Go ahead, David.
Yeah, I should say that one of them is newly discovered, and the other one is it's been on on my my tool chain for a long time now, but I always forget about it, and I always have to search for it every time I need it. I don't need it often, but I need it enough times that it's become a nuisance. So I'm going to talk about it today in the hopes that eventually I'll always remember it. So. Oh, and I do have some questions about that Solr stuff. That sounds fascinating. All right, so the 2 things I'm going to be talking about today are, the first one is going to be, excuse me, while I move, so Zoom is in my way and it's like annoying me. The first one is this thing called, it's a method inside mocks that's called without partial double verification. And basically what that does is that whenever you create a mock for something, you usually have to, in newer versions of like the mock library, whatever you're testing, whatever you're mocking, has to exist inside the object that you're mocking. So like if you're mocking a class called foo, and that that class has a method called whatever, let's just call it whatever, then it would be okay to like test whatever. But if you try testing something that's not inside, that's not defined by that class, whatever it is, right? So let's say you decide there's some foo method that you want to just try out, but it's actually not defined by that class, then you get this error. So like, I'll show you what that looks like real quick. So here I have a test, and it has this, trick in it. It's called the verification. Now, the thing that we are testing here is inside of this indexer, which currently is basically it's not necessarily being mocked, but it's being passed in, and then I think it into this environment via this let definition. So here, like if I were to try to do this is something I ran into very recently with my coworkers. If I were to try to run this and just say allow indexer to receive this mark fields thing that I've created, which is definitely not defined inside of traject indexer, what we get is an error. So an error, it will look like, let's see. Okay. Let's see. I'm gonna just and that's this is the first example. So the error looks like that. It's basically complaining. It's this failure error, and it's complaining that that mark fields isn't implemented inside indexer, which is correct. It's not. In fact, the reason that I'm, that I'm using that I need that is because I'm trying to create over here. I'm trying to create a value that's a variable that I could change the context of, right? And it's clearly not going to be inside of the indexer, class, but I need it, I need to create it in order to, like, in different contexts, update what mark fields is, right? Currently, by default, it's just that, but it could be other things in other contexts, and I want to be testing those things. So that's the first one. It's so we just add that without partial double verification, and that lets us then be able to pass this test without issue. So that's like the first one. It's actually pretty neat, and every time I need it, I forget about it. So hopefully I will not be forgetting about it anytime soon. All right, so the next one, it really is an RSpec trick, and it really is something that I learned recently. And basically, it's actually a combo sort of trick. You know that, like, inside RSpec, there's this way of allowing something like mocking an instance of something, and then allowing it to receive certain things, and then checking to see that the thing that it received is the thing that you want. And it's it's a very easy way to test, to make certain tests. So, like, for instance, an example of this would be like, I say here, these aren't the matchers. All right, so it's actually satisfy is the one. It's the matcher that I'm. But I think, let me just look into here real quick. Okay, so here's example number 2. So here we have a. This is very similar to what we saw before, where I'm testing something inside of this ingest class, and it's actually a wrapper for a traject library. And I'm wrapping some functionality, and I don't want to necessarily test, what traject is doing. I just want to test the bit that I'm adding to it. And the bit that I'm adding to it in this case is that inside of the, inside of this indexer instance, mark indexer instance, I am setting a config for a file name. That's the important bit that I want to test. And so, like, I could try to figure out, like, if I wanted to write a test where, I was making, I was figuring out, like, what, when this thing gets created, which I, inside the class I'm in, when it gets created, I could test to see that my, my method is passing the correct arguments to new. But it turns out that it's not a simple thing. So, like, if it were like a simple thing, like a string, like apple or something like that, I could very easily test that it return, that I'm passing in apple. But it could potentially be, a very complicated set of arguments, or it could be an argument that is hard to duplicate. And in this case, it was one of those arguments that was hard to duplicate. So I'll show you what happens in this case. I'm going to just put a pry in here before I talk about anything else, so you can see what's going on. So all right. I'm going to test sorry, actually see what I'm doing because of Zoom. All right, so here we're inside the test method. And you can see that, like, I'm passing in I'll call it settings here, but this could be any value. See what settings looks like. Would be it looks like this, right? So you see that it's a hash, or a dictionary, in other words, and it has like something that's really easy. This value here would be really easy to test, but something that's not as easy is this active record.model here, which actually is it's a record and it has a specific date time and a specific JSON, and these values exist outside the context of the test. So I don't actually have access to those. So in order for me to create like a mock of this, or to be able to satisfy, I would have to know what these are. Like I would have to know what string is in this case, and what outside of the test, which I have no way of knowing. And there are other examples, similar sort of situations, let's say, where for whatever reason, you don't actually have very sort of like quick access, or creating certain aspects of or whatever gets into it's going to be sort of difficult to do. And now the trick is that this width actually takes, one of the things that it takes is any acceptable RSpec matcher. And one of those acceptable RSpec matcher is this satisfy. That's the cool part. So we have like this right here, we have it talks about like these, this is all the things that width can do. And I've done all of these in the past, like width, like you can use it this way, you can do this. And at the very, very end, it says, oh, and by the way, any RSpec matcher will work. It's pretty cool. Like any RSpec matcher will work inside here. All you need to do is pass it in. And one of those happens to be like, if you look at the list of RSpec matchers, like all the things, one of them is satisfy. And satisfy is really neat, because satisfy basically says that anything that you pass into it, like it'll get the values, it'll hold the values inside of it. And it's not just one argument. You could have it be any number of arguments. For instance, and just to test this real quick, probably running into time right here, but you get the picture, I think. Let me exit. Go to here. What I'm going to do is, instead of I'll show you like I could turn this into like the first argument and the rest of them. Give me the first argument and the rest, and whatever the rest of them are. So I could say, and you can see like now the first one is that settings one. So I could test for anything inside this for truthiness or whatnot. I could check. Okay, its first file, which is what I'm testing, is first file name file.name.mark. Like great, I passed it, right? But I could also test, like, let's imagine that traject was more complicated and other things were being passed into it that I didn't know about, and I wanted to test. I could also get rest, but there isn't anything else being passed in. It's just empty. But you could imagine like this class, you could pass in 2 arguments, and then you could put argument 1, argument 2, and you could test what's in argument 1. You could test what's in argument, or test what's in argument 2. It's fascinating. It's fascinating what you could do with it, and it's something that I just recently stumbled onto. And it's sort of made certain types of tests, which for a long time I would have either skipped, because I had a really hard time figuring out, well, how would I do this, or even if I knew how to do it, I would be like, well, I don't want to spend creating these crazy mocks for all the arguments that are going inside just to like test this. I learned that, there's this really easy sort of satisfy, and satisfy can actually can do any sort of truthiness. So I could potentially satisfy something and just return true within, and it would be okay. But what I'm doing, you could also run expectations within the satisfy. So like an expectation within an expectation, and all of that stuff works. It's pretty, I find it pretty interesting, and I hope that someone else here is going to take something from it. All right, that's it for my lightning talk.
All right, thank you, David. We had one more scheduled from Eric Pugh, but are you in the room anywhere around here, Eric? All right, so I think we will skip that one. So I am going to is now, I believe we